Actually, what I gave you in that previous video is actually called the definition of the derivative. So this limit of f of x plus delta x minus f of x all over delta x as delta x approaches 0 is by definition the derivative of the function f of x. And as long as this limit exists, a function is differentiable at x. The process of finding derivatives is called differentiation. The function f of x equals square root of x, you might remember, was not differentiable at -1. First of all, because -1 was not in its domain, and then it wasn't differentiable at 0, and really the reason it wasn't differentiable at 0 is because at 0 you get a vertical tangent line. So, and then an alternate form that's used in business calculus generally is instead of delta x, we use h instead of delta x. But I'll do some examples in both forms. So now here's what you need to understand. Later we're going to learn properties that will make it easier to find derivatives. But what you need to understand, if your professor says use the definition of the derivative to give the derivative, again, if he says use the definition of the derivative, then you must use this limit to find the derivative. So that's the key. Anytime you say definition of the derivative, we're talking about that limit. So here I'm going to assume that we have to use the definition of the derivative to find the derivative of these functions. So here the derivative would equal the limit of the difference quotient as delta x goes to 0. Okay, so what would f of x plus delta x be? Well, you would have x plus delta x quantity squared minus 5 times x plus delta x. Then you would subtract f of x. So we would subtract the quantity x squared minus 5x. Now, if you square this, you're going to get x squared plus 2x delta x plus delta x squared. You distribute the minus 5, you're going to get minus 5x minus 5 delta x. If you distribute the minus 1, and this is where you got to be careful, make sure you distribute, you're going to get minus x squared plus 5x. Well, always on these polynomials, there's always going to be terms that cancel. So minus 5x plus 5x cancels, and x squared minus x squared cancels. Okay, so now you have 2x delta x plus delta x quantity squared minus 5 delta x. Now you can simplify this two ways. You can factor a delta x out of the numerator and cancel, or you can just say I'm going to divide delta x into each term on the bottom and each term on the top. So if you divide delta x onto the bottom, of course you just get 1. And if you divide the top, this term by delta x, it's going to cancel it. Divide this term by delta x, and you're just going to get delta x. And then if you divide this term by delta x, it's going to cancel it. So all you're going to have left is 2x plus delta x minus 5. And then you want to take the limit of that as delta x goes to 0. So as delta x goes to 0, you're going to get 2x plus 0 minus 5, which is simply 2x minus 5. And that is the derivative of the function x squared minus 5x. Now let's find the derivative of x cubed. I'm using the definition of the derivative. This time I'm going to use h instead of delta x. So I'm going to take the limit of f of x plus h minus f of x all over h. Well, f of x plus h, since this is x cubed, would be x plus h quantity cubed. And then minus f of x would be minus x cubed. Well, there's actually formulas that show you how to cube a binomial, but if you don't have that formula, you'll just have to go to scratch paper and work out x plus h times x plus h times x plus h the long way. But anyway, the formula is x cubed plus 3x squared h plus 3xh squared plus h cubed. And then you subtract the x cubed from all that. And then what's going to happen is x cubed minus x cubed cancels. So now you get 3x squared h plus 3xh squared plus h cubed. And then you can divide h into each of these terms. And if you divide this by h, it's just going to cancel it. If you divide this by h, you're just going to get 3xh. And if you divide this by h, you're going to get h squared. And of course, if you divide the bottom by h, you just get 1. So you end up with 3x squared plus 3xh plus h squared. And now you can take the limit of this as h goes to 0. And what that'll do is, since h is going to go to 0, the last two terms are going to disappear, and you're just going to be left with 3x squared. So the derivative of x cubed is 3x squared. Okay, I like to give you a really nasty one just so you can appreciate it once you learn the rules of derivatives, so that you don't have to actually go through this mess. But if we wanted to find the derivative of 3 over square root of x, we would have to use the limit of this difference quotient. So if I evaluate that function at x plus delta x, I would get 3 over square root of x plus delta x. And then if you subtract f of x, it would be subtracting 3 over square root of x. And then, of course, don't forget delta x in the denominator. Well, in order to simplify this, what I would need to do first is, since this is a complex fraction, I need to multiply the numerator of this by something that will eliminate these two denominators, square root of x and square root of x plus delta x. So what I need to multiply it by is this product. Now I can do that as long as I also multiply the bottom by the same thing. So basically on bottom I'm just going to have delta x times this product, and so you can see I have that right here. So that's just the delta x times that product. Now on top, when I multiply this on top, what's going to happen is, and let me just show you this here, here's what's going to happen. When you multiply this term by this product, the square root of x plus delta x cancels, and you just get 3 square root of x, which I have right there. And then when you multiply this term by that, well, this time the square root of x cancels, and you get minus 3 times the square root of x plus delta x. Okay. Now, before I go to the next step, notice I have a 3 here. I'm going to factor that 3 out of these two terms in the numerator. So I'm going to factor the 3 out of this and get 3 times the square root of x minus the square root of x plus delta x. Now, at no point so far could I plug delta x equals 0 in for delta x, because it would give me 0 over 0. So I'm still trying to get it into a form that I can evaluate by letting delta x equal 0. Alright, so now you might remember, so when we have a square root minus a square root, we can multiply by the conjugate, which is square root of x plus square root of x plus delta x. And then when we multiply these two together, square root of x times square root of x is just going to give me x. And then I'm going to have, when I multiply square root of x times square root of x plus, square root of x plus delta x times square root of x plus delta x, I'm going to get minus x plus delta x. Well, I'll let you do a little bit of arithmetic here, but basically this is going to be 3, or I'll do it for you here. That's going to be 3 times x minus delta x. And so the x's are going to cancel, so all you're going to have left is 3 times minus delta x. So the numerator is just going to be minus 3 delta x. Okay, so that's where this came from. Notice on the bottom, I did not try to multiply any of this together. There's really no need to try to multiply here, because what's going to happen in the next step is that the delta x's are going to cancel. Delta x over delta x is just going to give me 1. So on the top I have minus 3 times 1, which is just minus 3. And then on the bottom the delta x cancel. Now I can let delta x go to 0. And basically what's going to happen if delta x goes to 0, this term's going to disappear, and this term's going to disappear. And so here you're going to have square root of x times square root of x, which is just x. And here you're going to have square root of x times square root of x plus square root of x, which is 2 square root of x. So basically the denominator is just x times 2 square root of x, which I have here. And the numerator is minus 3. Now, since square root of x is the same as x to the 1/2, I went ahead and multiplied x to the first times x to the 1/2 and got x to the 3/2. So I write that as minus 3 over 2x to the 3/2. Now, one of the reasons I did that is so that when you once you get to the rules for differentiation, especially the power rule for differentiation, you'll be able to differentiate this function using the power rule, and you'll actually see that this is what you'll get if you apply the power rule. So now, differentiation notation here, there's a couple different ways that I will do this. Generally, if you're given f of x equals x squared minus 5x, you generally will say f prime of x is 2x minus 5. That's the derivative. If you're given y equals x squared minus 5x, and you want to stick with that theme, you can either say dy over dx, which means the derivative of y with respect to x is 2x minus 5. If you're given y equals x squared minus 5x and you want to just use y prime, then the derivative would be y prime equals 2x minus 5. You might also see this. If you have f of x equal x squared minus 5x, you might see a notation that says the derivative of f with respect to x is 2x minus 5. This notation is kind of a shorthand notation for when you just want to apply the derivative operator to a function. So if you apply the derivative operator to this function, you actually get that the derivative is 2x minus 5. And then this notation is usually used in differential equations, so I usually don't see this much in a calculus, Cal 1 course anyway. So those are just different ways that you can express a derivative. You can use f prime, you can use y prime, you can use dy over dx, you can use df over dx. And of course this is a little bit different because this is just applying the derivative to a particular function and giving you the result. That's pretty much it on this section, and so I'll move into the next section. We'll talk about properties of differentiation next.